Okay, this is Fall 2022 Calc 2 Final. Compute the following integral. This is in the form of a squared minus t squared. So this will be equal to, in this case, we'll set t is equal to a sine theta. So let's set t is equal to a sine theta, a being 5 sine theta. dt will be equal to 5 derivative of sine is cosine theta, d theta. Plugging this in, we're going to get the integral square root of plugging this in for t. We're going to doing some simplifications. We're going to get 25 and then 1 minus sine squared theta. And dt, replacing that with what it is, we're going to get 5 cosine theta d theta. Integral this 25, square root of 25 is 5 times this 5 will be 25 out in front. By Pythagorean identity, sine squared plus cosine squared equals 1. So 1 minus sine squared will be equal to cosine squared. And since this is under the square root of cosine squared is just going to be cosine. Cosine times another cosine will give you cosine squared. Theta, d theta. Applying our trig identities, cosine squared theta will be equal to 1/2, but you can bring that 1/2 in front, so it's going to be 25 divided by 2. Integral of 1 plus cosine 2 theta d theta. Integrating this, we're going to get 25 divided by 2 theta plus our antiderivative of cosine is going to be sine 2 theta divided by 2 plus c. Notice sine 2 theta, using double angle identity, we're going to get 2 sine cosine. So 2 sine theta cosine theta divided by 2, this 2 and this 2 will cancel. Therefore, we don't have to write this anymore. We just write it like this. Theta stays plus c, and everything else stays. 25 divided by 2. Notice we started with t. Now we're in theta, so we need to revert back to t. Notice t divided by 5 is equal to sine theta. So if we draw a triangle with this being theta, we know sine is opposite over hypotenuse, so it's going to be t over 5. So we know this adjacent angle is going to be t squared. Sorry, it's going to be 25 minus t squared by Pythagorean theorem. Now replacing everything with what it is, we're going to get 25 divided by 2. Theta, in terms of x, we can see it's going to be arc sine of t divided by 5. So inverse sine of t divided by 5 plus sine theta. Sine theta is going to be t divided by 5 plus t divided by 5 times cosine theta. Cosine is adjacent over hypotenuse. Looking at this triangle, we can see the adjacent is going to be 25 minus t squared over hypotenuse, which is 5, plus c. And this should be our final answer. Looking at this integral, this looks a little bit complicated, but once you realize the trick, it's not hard. So the bottom kind of looks like a quadratic. So we want to kind of think of partial fraction decomp. But how do we get in the form of partial fraction decomp? For example, let's say u is equal to sine. If we do this, our du will be equal to derivative of sine is cosine x dx. We see the cosine, and this cosine will cancel. This will leave us with 1 over replacing sine with what it is, which is u. We're going to get u squared plus 6u plus 8 du. Now, this is a form that we recognize. This is a partial fraction decomp. It's pretty basic. What are two numbers that add up to be 6 that multiply to 8? You're going to get u plus 4 and u plus 2. We can set this equal to a over u plus 4 plus b over u plus 2. Now if we multiply both sides by u plus 4 times u plus 2, we can see that 1 will be equal to a times u plus 2 plus b times u plus 4. If we set u is equal to negative 2, we're going to get 1 equals, this a term will cancel out. So b, u being negative 2 plus 4 is going to be negative, or it's going to be positive 2. So b times 2. So therefore we can see b is equal to 1/2. If we set u is equal to negative 4, 1 will be equal to negative 4 plus 2 is going to be negative 2a. B term will get canceled out, so a will be negative 1/2. Now putting all of this under the radical, or under the integral, we're going to get negative 1/2 of u plus 4 plus 1/2 of u plus 2. du. Now this becomes a very basic integral to integrate. It's going to be a negative 1/2 ln absolute value u plus 4 plus 1/2 ln absolute value of u plus 2 plus c. If you don't know how to do this, you can just set u plus 2 is equal to like a u sub. We can set it as a w sub, I guess. Either way, you'll end up with this. But notice we started with x, and now we're in u, so we need to replace u with what it is in terms of x. U is equal to sine x, so therefore, negative 1/2 ln absolute value of sine x plus 4 plus 1/2 ln of absolute value of sine x plus 2 plus c. This is our final answer. This will be in terms of x, which is what we started with. Determine whether each of these integrals converge or diverge. If the integral converge, compute it. Please make sure you use correct notation. Notice here, this is a improper integral, because when we plug in 0 at the endpoints, ln of 0 is undefined. ln of 0, we don't know what it is. It's a little, because the graph of ln looks like this, or whatever. Basically, it's undefined. So we have to write this as an improper integral, as a limit as, say, a goes to 0 from the right, because it'll be going, it's from 0 to 1, so it'll be going to 0 from the right. Integral of a to 1 of x squared ln x dx. This is a pretty basic integration by parts. Looking at LIATE, we see log comes first, so you will set u is equal to ln x. So du will be equal to 1 over x dx. Therefore, dv will be equal to x squared dx. And the antiderivative of x squared will be equal to x to the third power divided by 3. Okay, so applying our integration by parts formula, we're going to get x to the third power divided by 3 ln x, and evaluating that from a to 1, limit as a goes to 0 from the right, minus integral of v times du, which we can get a negative 1/3 out in front, because that's a constant, and x to the third power divided by x is going to be x squared dx. This is going to be equal to the limit as a goes to 0 from the right of x to the third power divided by 3 ln x, minus a 1/3 x to the third power divided by 3. Evaluating this from a to 1. Here we can see the limit as a goes to 0 from the right. We'll get x, actually we'll get 1 over 3 times ln 1, which is 0. So we don't have to worry about this term right now. Plugging in 1 for here into here, we're going to get a negative 1 times 1 cubed, which is 1, over 3 times 3, which is 9. We're going to get this minus, plugging a for everything, we're going to get a to the third power ln a divided by 3. minus a to the third power divided by 9. Notice this right here, this will go to 0. As a goes to 0, this term will go to 0. But we don't know what happens to this term. So we need to do some algebra. So, for example, so we can say because the limit as a goes to 0 from the right side of a to the third power ln a divided by 3, because this is equal to the limit, actually we can bring the 1/3 on front. So 1/3, the limit as a goes to 0 from the right, we can rewrite this as ln a divided by a to the negative 3. We want to rewrite this because then we can apply L'Hopital's rule to find the limit. This will be equal to 1/3, the limit as a goes to 0 from the right. Derivative of ln a is going to be 1 over a divided by a to the negative 3. Derivative of this will be a negative 3, a to the negative 2. No, negative 4. This is also, we can rewrite this as, let me write this on the bottom, will be equal to 1/3, the limit as a goes to 0 from the right, 1 over a divided by negative 3 divided by a to the 4th power. You can see this is equal to 1/3, the limit as a goes to 0 from the right. Take this, flip it, multiply, we're going to get a to the 3rd power divided by, would be a negative 3 like this. We can see this will go to 0. So now we know this will go to 0 too. So simply, we're just taking the limit as a goes to 0 from the right of negative 1 over 9, which is equal to negative 1 over 9. And this is our answer. Okay, this is a very basic, well, to set up this question is very basic what I mean, because we have the infinity sign here. So this is going to be equal to the limit as a goes to infinity, the integral from 8 to a of cosine squared 7x plus 6 over 4x minus 3 dx. Notice cosine, since it's being squared, this can be bounded between 0 and 1. So looking at something like this, we can conclude, if we say cosine, the lowest value is 0, we can say 0 plus 6 over 4x minus 3. This will be less than cosine squared of 7x plus 6 all over 4x minus 3. We can see this 3 is going to be making this denominator smaller. Making the denominator smaller is making a fraction bigger. Therefore, we can also say 6 over 4x will be smaller than this. Now that we have this, let's take the improper integral of this. So we can just say, since we know 6 divided by 4x from 8 to infinity dx will diverge because it's a multiple of a p-series. Basically, if you take the 6 divided by 4, bring it out front, it will give you this. 6 divided by 4 integral of 8 to infinity 1 over x dx. We can say it's a factor of p-series, where p is equal to 1. Therefore, it will diverge. And since this value right here diverges and it's smaller, we can conclude the bigger value will diverge by comparison theorem. Therefore, integral from 8 to infinity of cosine squared of 7x plus 6 divided by 4x minus 3 dx will diverge also by comparison theorem. Solve the following differential equation. Here, the first thing we should do is add this on the other side. So we'll end up with dy over dx will be equal to sine to the third power x cosine squared y. Now we can really easily be able to see that this is a separable differential equation. So our next step is to get all x's on one side, all y's on the other side. We can get 1 over y, 1 over cosine squared y dy will be equal to, multiplying dx over, we're going to get sine cubed x dx. Integrating both sides, we can see the left side will be equal to 1 over cosine is secant. So this will be secant squared y dy will be equal to integral of sine to the third power. Okay, so recall we can rewrite this as sine squared x sine x dx. Recall sine squared plus cosine squared equals 1. So therefore, sine squared will be equal to 1 minus cosine squared x. So the left side is really easy. The integral of secant squared y is just going to be tangent y. Tangent y, it will be equal to, we can rewrite this as 1 minus cosine squared x sine x dx. We want to do this because if we do u is equal to cosine x, du will be equal to negative sine x dx. We see this sign and this sign will cancel, leaving us with a negative 1, but we can bring that out in front because it's a constant. Negative 1 or negative integral of 1 minus cosine squared, which is u squared du. Integrating this, we're going to end up with negative u. Remember the negative sign to distribute it. We're going to get positive u to the third power divided by 3 plus c. Notice we started with x, now we're in u. So let's replace u with what it is in terms of x. So this will be equal to negative cosine x plus cosine cubed x divided by 3 plus c. This will be equal to tangent y. Solving for y, we're going to get y will be equal to arctan, or inverse tan, of everything here. Cosine x plus cosine to the third power x divided by 3 plus c. And this will be our answer. Find the solution to the following initial value problem. So we just did a separable, so most likely we're going to have a linear, and in this case we do have a linear. This is a pretty basic, we don't have to do any manipulations. We can immediately see this is the integrating factor. So basically it'll be e to the negative 3 divided by 2 plus x dx. This will be equal to e to the negative 3 integral of 1 over 2 plus x dx, which would be equal to e to the negative 3 ln absolute value of 2 plus x. If you set u equals 2 plus x and solve for du, blah blah blah, right? Here we can see this will be equal to e and ln will cancel, so it's going to be 2 plus x to the negative third power, which will be equal to 1 over 2 plus x cubed. We can set this as mu. So mu, multiplying mu by every single term, mu times y prime, dy dx, which is y prime, basically. This minus 3 divided by 2 plus x times mu times y will be equal to 6 mu. Applying our knowledge on implicit differentiate, or reverse implicit differentiation. I don't know why I can't say that, but yeah, you're gonna get mu times y. If we get the derivative of this, this will be equal to 6 mu. If we integrate both sides, of this, the integral of a derivative is just whatever's on that side. So it's going to be mu times y, replacing mu with what it is, which is 1 over 2 plus x to the third power. This will be equal to, we see here we have a 6, so we can bring that in front because it's a constant. 1 over 2 plus x to the third power dx. Here we do a basic u sub. If we set u is equal to 2 plus x, du would be equal to dx. Therefore, u over 2 plus x to the third power will be equal to 6 integral of 1 over u to the third power du. We can see this is going to be equal to, u, where actually this will be like this, integral of u to the negative 3 du. Integrating this, we're going to get u to the negative 3 plus 1, which is going to be negative 2 divided by 2. So u, can't forget the 6, u to the negative 2 divided by negative 2 plus c. This will be equal to 6 divided by negative 2 is going to give you a negative 3. And u squared will be on the bottom. I think that's right, plus c. So y is equal to 2 plus x to the third power. Replacing u with what it is, we're going to get equals to negative 3 divided by 2 plus x plus c. Y over 2 plus, this is squared, I forgot, u plus x to the third power. Okay, so we're given an initial value. When x is equal to 0, y is equal to 1. So let's put that in. Y is equal to 1 when x is equal to 0. 2 to the third power is going to be 8. This is going to be equal to negative 3 over 2 plus 0 squared is going to be 4 plus c. So therefore c will be equal to 1 over 8 plus 3 over 4, which will be equal to, what, 7 over 8. So y will be equal to negative 3 divided by 2 plus x squared plus c, which is 7 over 8. Multiplying this by this term right here on the bottom will give us y. So 2 plus x to the third power. You can simplify this and this, you can multiply this in, but this should be correct. There's no point to do more work when it's unnecessary. Determine whether the following integral or following series are divergent, conditionally convergent, or absolutely convergent. Justify your answer. You do not need to compute sum. Looking at this first one, we can immediately see this is a ratio test. So let's write our ratio test. And let's apply the ratio test. The limit as n goes to infinity with the absolute value of n plus 1 over a of n. This is going to be equal to the limit as n goes to infinity of, we can ignore this term right here because the absolute value cancels it out basically. This will be an n plus 1 factorial, all being squared. This will be over 2n plus 1, 2 times n plus 1 is going to be 2n plus 2 factorial times 2n factorial all over 2n factorial. This is equal to 2n factorial. This is the same thing because if you distribute the factorial n, 2 factorial is just 2. So we can rewrite this later. This would be a 2, this would be a n factorial squared. We can see there's no x's in this, so we can drop the absolute value sign. This is going to be equal to the limit as n goes to infinity. Here, let's write this out. Let's write this out as n plus 1 factorial times n plus 1 factorial. To make it more clear, this will be divided by 2n plus 2 factorial times 2n factorial all over this right here will be n factorial times n factorial. Now we have to know that n plus 1 factorial is equal to n plus 1 times n factorial. So we can replace each one of these with this. Doing so, we can see that this and this will cancel with this factorial and this factorial. From there, this will be equal to the limit as n goes to infinity of n plus 1 times n plus 1 all over. This right here, we can pick off terms. 2n plus 2 times 2n plus 1 times 2n factorial. We see this 2n factorial and this will cancel, leaving us with just this. So we can put this here. Now that we have this, let's see what the limit is as n goes to infinity. This is going to be equal to the limit as n goes to infinity. Multiplying the top thing, we're to get n squared plus 2n plus 1 all over. Multiplying the bottom, we're going to have 2n times 2n, so it's going to be a 4n squared. And then 2n times 1 plus a 2n times a 2n. Sorry, a 2 times a 2n. This would be a 4n plus 2n, which is going to be 6n. Plus 2 times 1 is going to be 2. Now, if we multiply the top by 1 over n squared, and multiply the bottom by 1 over n squared, this is going to be equal to the limit as n goes to infinity of 1 plus 2 divided by n plus 1 divided by n squared, all divided by 4 plus 6 divided by n plus 2 divided by n squared. This is going to be equal to 1 over 4. Because this term will go to 0, this term will go to 0, this term will go to 0, this term will go to 0. So we're just left with 1 over 4. Therefore, we can conclude this is less than 1. Therefore, by ratio test, since this value is less than 1, the series converge absolutely because this is less than 1. We need to see if this is convergent, divergent, or absolutely convergent, or conditionally convergent, or whatever. So, to do this, we can see this is a very basic divergence test. A lot of people miss this. They overthink this. But basically, the first thing I thought about is I ignored this and just took the limit of this. Taking the limit of this, we know it's going to be 1 over 5, which is not equal to 0, therefore it's going to diverge either way. And plugging this in, it's going to alternate back and forth. Therefore, the limit of this absolutely does not equal to 0. So the limit as n goes to infinity of negative 1 to the n power n squared plus n, all divided by 5n squared plus 4n. We know this part right here is equal to 1 over 5 once we take the limit as it goes to infinity. And this just makes it alternate negative 1/5, positive 1/5, whatever. So we know this is not going to equal to 0. Therefore, by divergence test, series will diverge because it doesn't equal to 0. Consider the series. Determine the radius of convergence of the series. When you see radius of convergence, you usually want to think about almost 100% of the time, like 99% of the time, you're going to do like ratio test, right? So for this one, let's do a ratio test. The limit as n goes to infinity of the absolute value of a of n plus 1 over a of n, we can write ratio test This will be equal to the limit as n goes to infinity, the absolute value of x plus 2 to the n plus 1 over n plus 1 times 2 to the n plus 1. You really do not want to be wasting any time on these, so you can write them pretty fast. Try not to make any mistakes, obviously, but you don't want to be wasting time on easy stuff like this. This is just a bunch of like busy work, I would say, ratio test, because it just takes a bunch of time. This and this will cancel, leaving us with the x plus 2 on top. And this 2n, 2 to the n power is going to cancel with this 2 to n, leaving us with 2 on bottom. This n divided by n plus 1 doesn't cancel, so we'll leave this here. Notice we can bring the constants, which is the x plus 2 divided by 2 out front. This is going to be equal to the absolute value of x plus 2 divided by 2, the limit as n goes to infinity of n divided by n plus 1. Multiplying this top and bottom by 1 over n. I really hate that they have to make you do this, but it is what it is. This is going to give you the absolute value of x plus 2 over 2 times the limit as n goes to infinity of 1 over 1 plus 1 over n. This is going to go to 0, therefore this is just going to be equal to x plus 2. This term right here is going to equal to 1. So it's going to be x plus 2, absolute value x plus 2 over 2. So absolute value x plus 2 over 2, this needs to be less than 1 for it to converge. Therefore, if we multiply the 2 on the other side, we're going to get x plus 2. Absolute value x plus 2 is less than 2. So we can see our radius of convergence is 2. Now it wants us to find the interval of convergence. We know that the absolute value is a piecewise function. So we're going to have x plus 2 is less than 2, and then at negative x minus 2 is less than 2. To find an interval of convergence, we need to find our endpoints and then test to see if they're convergent or divergent by plugging them back into the series. So we can see in this first one, we're going to get x is less than 0. The second one, we're going to get negative x is less than 4. Therefore, x is going to be greater than negative 4. So we're going to have negative 4, which is less than x, which is less than 0. We need to see if negative 4 and 0 is convergent or divergent at these two endpoints. When x is equal to negative 4, plugging it back into here, we're going to get negative 4 plus 2, which is going to be a negative 2. N equals 0, I believe, right? N equals 1. And we said it was going to be a negative 4 plus 2, which is going to be a negative 2 on top to the n power divided by n 2 to the n power. We can see here, this and this, basically this, we're going to have a negative 1 to the n times 2 to the n on top, and then the 2 to the n on the top and the 2 to the n on bottom will cancel, leaving us with a negative 1 to the n times n, or divided by n, sorry. We can see this will converge by alternating series test. Converge by alternating series test, where b of n is equal to 1 over n. And this must be continuous, positive, I can't spell, b of n is greater than 0, there we go, 0. Continuous, positive, decreasing because denominator is increasing, and the limit as n goes to infinity of 1 over n is equal to 0. Because all 4 of these conditions are met, we can say this is convergent by alternating series test. When x is equal to 0, which is our other endpoint, we're going to get a summation of n equals 1. Remember, it's going to be 0, or it's going to be x plus 2, and x is going to be 0, so it's going to be 0 plus 2, 2n divided by n to 2n. This is going to be equal to 1 over n. And we know this is going to diverge because it's a harmonic series. Which is going to diverge by harmonic series. Or diverge by p series where p is equal to 1. So we can see whenever x is equal to 4, it will converge. And when x is equal to 0, it will diverge. So our interval convergence is equal to square brackets, -4, comma, 0, parentheses. I should probably write this a little bit better. There we go. Find a power series representation for this. This is actually quite tricky. If you don't recognize this form immediately, you're kind of just screwed because there's no other way to do this if you don't recognize the form. 1 over 1 minus x. If we take the derivative of this, if we take the derivative, if we differentiate this actually, we're going to get 1 over 1 minus x squared. Applying the quotient rule, you're going to get this, which is equal to this. Okay, so basically from this knowledge, we know 1 minus x will be equal to summation n equals 0 of x to the n power. This is going to be equal to, say, if we plug in 0, we're going to get 1 plus x to the first power plus x to the second power plus x to the third power. If we differentiate the left side, we're going to get 1 over 1 minus x squared. If we differentiate the left side, we should differentiate the right side. It's going to be 0 plus, derivative of 1 is going to be 0, derivative of x is going to be 1 plus x, actually plus 2x plus 3x squared plus dot 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 and so on. So therefore, we can see this is going to be equal to nx to the n minus 1. Basically, looking at this, x to the n power, if x is a variable and n is a constant, taking a derivative is bringing the power down in front and subtracting that by 1, the power by 1, which is what we have here. This will not be on the new exams, so we don't need to worry about that question. Find the Taylor series for this centered f, a equals 5. So, f of x is equal to e to the 4x. So f prime of x will be equal to e, it will actually be equal to 4e to the 4x. F double prime of x will be equal to 16, which is 4 squared e to the 4x. F triple prime of x will be equal to 4 to the third power e to the 4x. F of 5 will be equal to e to the 20. F prime of 5 will be equal to 4e to the 20. F double prime of 5 will be equal to 4 squared e to the 20. F triple prime of 5 will be equal to 4 cubed e to the 20. So given this, and we know that the Taylor series will look something like this. Actually, we can say in general. Let's say this one first. In general, f of centered at 5 is going to be equal to, we can see there's 3 here, there's 2 here, there's 1 here. We see there's 3 here, 2 here, and 1 here. So we can say 4 to the n power times e to the 20. And we know Taylor series looks something like this. F n a divided by n factorial times x minus a to the n power. So, therefore, plugging in what we know, Fn of a centered at 5 is going to be 4n e to the 20 divided by n factorial. a, a. A is going to be equal to 5. So it's going to be x minus 5 to the n power. And this is our Taylor series, centered at a equals 5. Compute the degree 2 Taylor polynomial of this, centered at 0. So to do this, let's do f of x will be equal to 9 plus x, square root of 9 plus x, which is equal to 9 plus x to the 1/2 power. F prime of x will be equal to 1/2 9 plus x to the negative 1/2 power. F double prime of x will be equal to negative 1 over 4 9 plus x to the negative 3 over 2 power. Because it's only 2nd degree, 2 degree, we don't have to keep going on. Let's just see if this is good enough, because if we differentiate this again, it'll be quite complicated, and I don't really feel like doing it. So let's just stop here. Centered at 0, f of 0 will be equal to square root of 9, which is 3. F prime of 0 will be equal to 1 divided by 2 times 3, which is going to be 1 divided by 6. F double prime of 0 is going to be equal to negative 1/4 times 1 over 9 to the 3 divided by 2 power. Square root of 9 is 3, so it's going to be 3 to the 3rd power. Like this. Therefore, the Taylor series for 2nd degree of f of x will be equal to something. It will be equal to 3. If we wrote the Taylor series, it's going to be, what is this? F of n of a divided by n factorial times x minus a to the n power. So, plugging in n equals 0, this will be 1. This will be anything to the 0 power is 1. So it's just going to be this, which is just going to be 3. Plus, you're going to have 1/6 divided by n factorial, which is going to be 1 factorial, so it's just going to be 1/6. And then x minus a. A is 0, so it's just going to be x times x. Plus negative 1/4 plus a negative 1/4 times a 1/3 to the 3rd power. And then it'll be x minus a. A is 0, so it's just x squared divided by 2 factorial, which is going to be 2. So this is the 2nd degree Taylor polynomial to the 2nd power, so 2nd degree. Use the Taylor polynomial fund part A to approximate the value. This is a very interesting problem, because I doubt that anybody has learned this in class. But basically, we see this is this. So if we rewrote square root of 10 to be equal to square root of 9 plus 1, we can see that this x is equal to this 1. So we can say x is equal to 1. So based on this, if we just replace every single x we see with 1, that's approximately what 10 is going to be equal to. So 10 is approximately going to be equal to 3 plus 1 over 6 times 1 is just 1 over 6, minus 1 over 4 times 1 over 3 cubed times 1 over 2. We're given that u, v, and w are vectors. So when we do a cross product of two vectors, we're going to have a matrices of I, j, k, and then blah, 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 blah. This will make us have a vector. So cross product of two vectors is a vector. Now we have a vector dot a vector. A vector dot vector is going to give you a It's going to give you a scalar, sorry. So this will be a scalar. So now we have u dot v. Vector dot vector. We said that earlier it's going to be a scalar. It's going to give you a number, basically, which is a scalar. A scalar time. So we have a scalar dot a vector. This doesn't make sense. We can't do this. So this does not make sense. We can't have a scalar dot vector. For a dot product, you need to have two vectors. Let u, v, and w be non-zero vectors. Okay, this is a very interesting question because if you don't know the formulas, if you don't know the identities, you're kind of just cooked, basically. So basically, is A orthogonal perpendicular to W, where U? We know that A will be A dot U if this is equal to 0. Therefore, they will be perpendicular or orthogonal. This right here is kind of complicated. This is a vector triple product identity. A vector triple product identity basically puts us at A equals U. Oh, what is it? It's U dot a W, this dot this, times a V minus U dot V times W. If we need to know what A dot W is, so let's multiply dot product of U on both sides. So we can see here, U dot A is going to be equal to U dot W. We're not going to have enough room. Great. Let's put that here. Distributing this like dot un, we're going to get U dot W is going to be equal to, where it's going to be multiplied by V dot U minus U dot V W dot U. We can see this, and this. They're all the same thing, so they're all just going to cancel. This is equal to 0. So therefore we can say confidently this is yes. This will be perpendicular. Is A orthogonal to V? Is A orthogonal to V? So now, think about it like this. V, this is V. Dot, a dot. Now what do we have? Now we have V dot A is equal to U dot W V dot V minus U dot V W dot V. We don't have enough information to tell if this is going to be equal to 0 because they're not all equal. Therefore, there's some chance, there's some possibility that this is not equal to 0. Therefore, we don't have enough information. If A of n is a sequence and the limit of this is equal to 1, the series must, well, if it's equal to 1 by ratio tests, by ratio tests, if it's equal to 1, it's we don't know if it's like convergent. It's inconclusive by ratio test, and this is the ratio test, so this one's pretty basic. Find the line of intersection of the plane this and this. We're given two planes. We need to find the line of intersection. Remember, the equation of the line, we need two things. We need the direction and a point. We need a point and direction. How do we get a direction? We get a direction by doing cross product. So, for example, if V is equal to this first, which is going to be 2, 1, negative 1, and we said W, vector W, is equal to X, which is 1, Y, which is 1, Z, which is 0. If we did cross product of this, V cross a W, this will be equal to I, J, K, 2, 1, negative 1, 1, 1, 0. Which will be equal to I 1, negative 1, 1, 0 minus j 2, negative 1, 1, 0 plus k 2, 1, 1, 1. We can see here this will be equal to I 1 times 0 is 0 minus a negative 1 is going to be a positive 1 minus j 2 times 0 is 0 minus a negative 1 is going to be a positive 1 plus k. I don't know why I keep writing the line on accident. 2 times 1 is 2 minus 1 is going to be 1. So here we're going to get the vector 1, negative 1, and 1. So we have a direction vector now. Now we need a point. How can we find a point? A point of intersection, we can simply just... How do we do this actually? Let me think. Let's say if we set x equal to 0, right? If x is equal to 0, will they intersect? Where will they intersect if x is equal to 0? When x is equal to 0, look at the second equation. Y will be equal to 4. If x is 0 for the first one, we're going to y minus z is equal to 3. Y minus z is equal to 3. We know y is equal to 4, so it's going to be 4 minus z is equal to 3. So we can see here that z is added over, subtract negative 3 over, we're going to get z is equal to 1. So they'll intersect at the point 0, 4, negative 1. And this is a point. Now we can write the equation of the line. The equation of the line, x, y, z, will be equal to the point 0, 4, negative 1. Why did I write negative 1? Sorry, this is just positive 1. I don't know why I wrote negative 1. Plus t times the direction, which is going to be 1, negative 1, 1. We can see here, x will be equal to t. Y will be equal to 4 minus t. Z will be equal to 1 plus t. Determine the following two lines are parallel, skew, or intersecting. Okay, so we need to see these are all parametric equations. If we set this is equal to t, this is equal to w. We can see that for L1, we're going to get x is equal to 2t. Y plus 1 is equal to 3t. Z minus 1 is equal to 2t. Solving this a little bit, simplifying this a little bit further, we're going to get y is equal to 3t minus 1. While z is going to be equal to 1 plus 2t. From this, we can see the direction of this line is going to be equal to 2, 3, and 2. For L2, line 2, we will get x is equal to 4w, y is equal to 5w, and z is equal to 5w. From this, we can see direction is 4, 5, 5. So we can conclude because L1 and L2's direction are different, line are not parallel, they're not parallel. So we need to see if they intersect where they're skew. Let's set x equals to x, y equal to y, and z equal to z, and see what happens. For line 1, x is equal to 2t. Set that equal to line 2, which is x is equal to 4w. Based on this equation, we can conclude t is equal to 2w. Now let's set y equal to y, and see what happens. Y for the first equation is going to be 3t minus 1. Y for the second equation is going to be equal to 5w. So we can see in this case, if we plug in t, we're going to get 6w minus 1 is equal to 5w. We can see from here that 6, subtract that over, we're going to get negative 1 is equal to negative w. We can see w is equal to 1. Now let's set z equal to z. Z for the first equation is going to be 1 plus 2t. 1 plus 2t will be equal to z for the second equation is 5w. Now let's plug in. Oh yeah, based on this, w equals 1, we can say conclude that t is equal to 2. So let's see if this is true. 1 plus 2 times 2, which is 4, will be equal to 5 times 1, which is 5. And therefore 5 does equal to 5. So they do intersect. They intersect at x is equal to 2t. 2t, and t we said was 2. 2 times 2, which is 4. The point 2 comma y is equal to 3t minus 1. 3 times t, which is 2, which is going to be 5. And z, which is going to be 1 plus 2 times 2, 2t, which is going to be 5. So they're going to intersect at this point. And that's it.